Boa tarde, você que está participando do rodaTECH. Estamos ao vivo agora com o nosso convidado Hakim Laghmouchi, doutor pela Universidade Técnica de Berlim, e também nossos amigos Vinícius Ferro e Rafael Amorim. Vamos começar aqui rapidamente. Nosso tema hoje é falar um pouco sobre as tendências da transformação digital e também da Industrial IoT, né, que é a Internet das Coisas Industrial. Pessoal, esse vai ser um rodaTECH internacional, então sejam bem-vindos. Welcome, Hakim. Seja bem-vindo, Rafael. Seja bem-vindo, Vinícius. Vou deixar eles se apresentarem, depois eu passo para o Hakim. Então, eu sou Rodrigo Pachli, sou cofundador e CEO da Lean 4.0. Rafael.
So I talk in English right now or in Portuguese? Em português, ok. Bom, meu nome é Rafael de Amorim Silva, sou professor do Instituto de Computação da Universidade Federal de Alagoas e sou pesquisador em 3 áreas, Internet das Coisas, Inteligência Artificial e Engenharia de Sistemas voltadas aos domínios de educação e saúde, healthcare. Então, muito obrigado aí mais uma vez, né, por estar participando conosco, e a ideia é a gente estar interagindo com o Hakim, que tem uma grande experiência em Indústria 4.0, né, e ele vai falar um pouquinho sobre a experiência dele, e a ideia é a gente tentar criar aí um rodaTECH diferenciado, internacional, acho que vai ser bem legal para todos. Então, vamos lá.
Vinícius, hoje temos som?
Será que dá para me escutar?
Ah, tá funcionando.
Agora eu tô esperto, garoto. Beleza, pessoal. Uma boa tarde para todos que estão nos acompanhando aqui. Eu sou Vinícius Ferro, eu sou da área de gestão, né? Então, minha especialidade e a propriedade intelectual é a transferência da tecnologia para inovação, e aí esse rodaTECH vai ser muito bacana, né? Então eu vou ficar aqui atento, né, a toda essa expertise da indústria 4.0 aí com o Hakim.
Então a gente vai agora chavear para o inglês. Hakim, thank you very much for accepting this invitation. Your expertise would be very useful for us. So please let us know who you are and what you do. Thank you very much again, and we hope that all the people that are watching us really enjoy this interview, this panel, this conversation. So, man, it's all about you right now.
Thank you very much. Thank you for the invitation for this interesting panel discussion. So, Hakim Laghmouchi, have been working in the environment of Industry 4.0 for the last 13 years. I'm a solution architect for IIoT solutions in manufacturing at Capgemini Altran Group. Based in Dubai, I am dealing with all applications in manufacturing, applying Industry 4.0 technologies to enable increase in the production flexibility, reducing costs. We have also many applications in healthcare we are going to talk about, and in the other domains. So my background is computational engineering science at the Technical University of Berlin. After I completed my degree, I started to work for Fraunhofer Institute for Production Systems and Design Technology, where I met Rodrigo, where we did our PhD together in the same department. I was dealing there with applications in the field of condition monitoring in Industry 4.0. So edge computing, analytics, which we are going to talk about in this session. Rodrigo, should I continue?
Áudio fechado, Rodrigo.
Sorry. I was talking about we want to try some context of the Industry 4.0 right now in the world, and we also have in Brazil, like it's happening everywhere because of the digitalization of the industry, and also all the services and all the logistics everywhere. And one of the question is, what do you consider it's relevant to develop a good project in this topic, in Industry 4.0 or digital transformation? What do you think is important so we can develop a good project?
I mean, in Industry 4.0 environment or an Industry 4.0 project is an interdisciplinary project. So it means you need knowledge from different domains. So for example, if we take an application in manufacturing, so as an example, enabling data-driven services for operators, an example is predictive maintenance. We are going to talk about it later on. Then you need different technologies that should be applied to enable or to implement an Industry 4.0 project. So starting from the shop floor when it comes to the connectivity of the devices in the field. So a device can be, for example, an electric engine, which should be monitored because it's a critical component, or a pump, for example, or any other components in a production plant or a robotics. And from that level, we need we need knowledge how to gather the data, how to use different industrial protocols. We have different vendor in the production, different vendor means different devices using different protocols. So we don't have a standardization. So means we need some experts who understands different protocols, different device protocols, communication protocols, to bring this diversity in the field, in manufacturing, for example, to one system. And then you need, when it comes to communication, one of the critical topics is security. So when I communicate the information from the machines, process information, critical process information, we should make sure that this information are transmitted in a secure way. So it means we need cybersecurity experts that can enable the networking when it comes to the connectivity, the connections between the machines and the IT environment in the factory. So there we need expert from cybersecurity. And then when we have finally details, insights, so means information, sensor data, for example, from the machines, from those devices, then we need someone who understands how to analyze this data. So data analysts or data scientists. So then it became so so you need an interdisciplinary team who can solve these kind of challenges. In my based on my experience on the projects we had with different manufacturers, with different factories, it's always necessary to have a clear definition of the target, of the objective of the project. So means the business case should be clear. So what is the target of implementing, for example, data analytics for a production line, as an example? So is it about reducing the production costs? Is it about reducing the maintenance costs? Is it about increasing the transparency in the production? And this should be very clear. Then the next step is to start with a pilot project, which not is as complicated. I mean, it should be as simple as possible. And then when these pilot projects, when the outcomes of these pilot projects are clear and meets the target, I mean the business target, then it can be scale in the factor. So that's what how we applied different technologies in this field. So to summarize my answer, Rodrigo, so you need an interdisciplinary collaboration between different experts in the factory. And you need a clear business goal definition with with the KPIs which are measured to be met with that project.
Okay, great. You need to bring different know-hows and expertise from different people, like you said, data scientists, engineers, other kind of professions, like also psychology, for example, inside of a company, an industry. You should have some different points of view, so you could put it on a pilot project, right? So you can have more. That the project should be more richer than something quite simple, but it should be simple, but not that simple. I mean, you need to have different backgrounds inside, right?
Yeah, I mean, it's always very important to include all the stakeholders. So starting from the operators of the machine, then the next level will be the production managers who understand the production better, who understands the challenges in the production. And then you go to the next levels where you need cybersecurity experts. Then you need people who can apply data analytics or AI and machine learning, so artificial intelligence, or part of it, machine learning algorithms to the data to get the insights which will help to meet the KPIs or the business objectives.
Great.
And then
you need to have the purpose, right?
Yes.
So
I mean, many companies, they don't know exactly where they can start when it comes to Industry 4.0. So the objectives are always similar. So it's always about reducing the costs. So reducing the costs means operation costs, for example, being flexible in production, so reducing the time to market, so means being flexible when the products change, so that the development is faster, as we know. So how we can meet these challenges using Industry 4.0. So many companies, for example, they don't have they have part of the requirements which you need to enable data-driven services, because industry, when we say Industry 4.0, one of the large part of it is data-driven services. So means when you connect operators with machines, with objects in the factories. So objects can be any transport vehicles in the production for logistics, for intralogistics, and any other peripheries in the factory. So when it comes to this connectivity, you have a huge of data which is gathered at different devices at different locations in the factory. So and then it's about how to aggregate, how to bring this data together to apply machine learning algorithms to get some insights, to increase the transparency in the production, to identify the pain points in order to implement solutions directly to improve these pain points or to solve the challenges you have in the production.
It's great. Rafael, do you have any questions that you want to?
Yes, I have one question.
Yes, yeah.
So, Hakim, tell us a little bit about the usage of emerging technology in the Industry 4.0 field. For example, can you give some example for using artificial intelligence techniques, yes, or how can we integrate the Internet of Things and the artificial intelligence techniques? So if you can show us some examples, yes, about the usage of these technologies.
Yes, for sure. So one of the challenges, as I said, in the production, if we focus on manufacturing, is reducing the operating costs. The operation costs, which can be, for example, reducing the maintenance costs, so increasing the machine availability, the production machine availability. So one of the applications in this environment is predictive maintenance, or the first stage of it, which is condition monitoring, where we apply an emergent technology, which is internet, industrial Internet of Things, and then the analytics based on artificial intelligence, machine learning. So, for example, for this example, how we can apply these technologies to enable cost reduction is we identify the critical components in the production. Critical components can be a pump, for example, which always causes an interruption of the production, can be about any other mechanical components of the production lines, production machines, robots, or intralogistic vehicles, for example. And the challenge is how to implement maintenance strategies based on the conditions. So means the reaction of the maintenance technician is based on the condition of the critical components. So there we use the Internet of Things capabilities and technologies to enable data communication. So means I have a physical component, a moving part, for example, and then we need to gather data. Sensor data can be temperature, for example, can be vibration. So any diagnosis signal which can be used to monitor the condition of the component. And when we use the sensors, we need to transmit this sensor to another system where we can merge it with the other information from the factory. So then the first level is at the location where we gather the data, how we can go further with this data, how this data can be used on for further analytics. So then one of the challenges here when we have what we have in the production is the latency of which is often very critical when it comes to security and safety in the production. So where you have processes which are very fast, so you need to react also very fast. So means when you transmit these data to further systems in the factory, the latency is higher, than the decision or the analytics and the response takes a lot of time. Then the first ideas, or one of the trends in this context, is edge computing. So means where I gather the data, I try to analyze it near the location where I gather it. And what how we can apply the artificial intelligence or machine learning algorithms in this context is how to enable filtering, for example, of specific signals. So how to make from a huge data which is gathering at the components a smart data which can be transmitted and used on the other systems. An example which we are always coming across it is condition monitoring, as I said, or predictive maintenance. So means I need to monitor critical components in the factory, so transmit, and so using sensor data to have insights, to have a real-time or near real-time information about the condition. And there we use Internet of Things or components to transmit this information to a gateway, for example, or an industrial computer, where we can measure this sensor data with other information from the machine to provide insights, for example. So your question was how we can apply artificial intelligence, machine learning in different applications of Industry 4.0. It's the one of the applications, or one of the implementations ideas of Industry 4.0 is to enable smart factory. And smart factory means all decisions or decisions making in the factory are data-based or data-driven. So means data-driven planning for the production, data-driven maintenance, data-driven logistics. And for these data-driven services or applications or insights within the factory are enabled using artificial intelligence or data analytics techniques. Part of it is machine learning. So it means when it comes to identifying pattern in the data and reacting based on this is the application of the machine learning in manufacturing or for decision data-driven decision support.
Okay, so the two main points are where you get the context, you get the location, and when you can use artificial intelligence or machine learning techniques closer to the IoT sensors. So I mean, we have a lot of research about that, but I don't know if the industry 4.0 is applying, but I believe it's very interesting to bring the processing closer to the IoT sensors, because the sensor is there all the time to get the data, and the main goal is perceive when this data is useful to pass to forward the network. So it's very interesting to use the machine learning in edge networking, in edge computing.
Yes.
Perfect.
Yeah. I mean, in this context, there are two challenges. So one of the challenges is that when you go to any manufacturer, to any factory shop floor, you will face or you will see that there are new machines. So new machines means machines which can have these capabilities. They have the connectivity capabilities. They are enabled to communicate to the other systems. You can even implement machine learning algorithms on the industrial computer of the machine. And then you have the old machines, or you have some other devices in the field, so like pumps, for example, which are individual components with old protocols, or where they don't even have the sensors that can be used for monitoring. And then it's interesting to enable these components with IoT devices. So an IoT device with the sensors that can gather different information that can be used depends on the application. So if I have, if the target critical component is a rotating component, then it's vibration likely to use, because it's widely used in this environment. Then I need a vibration sensor, and the vibration sensor can have the capability to analyze data, which many companies right now they are working on how to bring this intelligence into the sensor. So it means the future sensors will be enabled to analyze the signals with their internal processors. And then after I analyze this signal, I can, or this sensor data, I can send the result to another system where the other information or the other insights from other critical components are sent to get to be immersed together, or to be aggregated together to provide the insights of the whole machine or the condition of the whole machine. So Internet of Things or IoT devices in this context, they can be applied to the existing plants. So it means plants which are not able to communicate with plug-and-play solutions. So it means I bring an IoT device that has the capability for processing, where I can implement open source algorithms and with the sensors to enable the condition-based maintenance or monitoring.
Perfect.
Perfect. Great. Vinicius, do you have a question?
Very good. My question, Hakim.
Yes.
In your opinion, which are the most important emerging technology for development the Industry Doc Zero?
I mean, there is not only one technology. I think all the technologies are important to enable a smart factory. So, for example, we need, when it comes to transforming digital transformation in manufacturing, so which means transforming the, manufacturing in a data-driven decision making support factory. We need different technologies. So the one of the technologies which should be available and should be applied is the Internet of Things for connectivity. So in a smart factory, we have there is a networking between machines, operators, and any objects in the factory. So other objects can be, as I said, the intralogistic vehicles or machine or any tools or any devices in the field. And the next level is then the analytics. So it means when I have data, then I should use then the big data and technologies. So it means storage, data management, and then the analytics, which is based in artificial intelligence, machine learning. But when it comes to aggregating these data on the cloud level, for example, so from different production locations, then I need cloud technologies. So cloud technologies enables Industry 4.0 to manage the data management from different factories, and then also provide the computer power which is needed to analyze a large amount of data and to enable identifying anomalies from different, for example, production units. And an important point is also how to link these information or the insights from the production with the other IT systems in the factory. So, for example, an enterprise production planning system, and a product lifecycle management system, and any other IT system in the factory where I can use order information, I can use customer feedback from a customer relationship management system. Then I can generate more insights and more business insights for the business unit, but also for the whole factory, for the whole enterprise. And one of the trends, as I mentioned before, is how to enable real-time monitoring, how to enable, how to reduce these large amount of data transmission is with edge computing. So where I bring the intelligent closer to the location where is needed, and only part of the data, only and then outcomes is transmitted to the next level. Another emerging technology, which is also it's one of the trends right now when it comes to support the operators in the production or in the logistic, is virtual reality or augmented reality. So it means where you have the Google Glass or any other vendor glass supporting the activities inside the factory. So an application is, for example, the virtual commissioning. So someone is on site in front of the machine, is doing the procedure for commissioning of a new installed machine, and there is an operation room from the central unit of the manufacturer, which support this guy with or this machine technician with the virtual reality technologies. But virtual reality technologies or augmented reality can be used also when it comes to the assembling of a new product. So then you don't have, for example, to go each time to the computer and then look how is the next step, look to the procedure. So you have these steps displayed on your glass, and then you can work faster, you can manufacture faster, you can identify also the failure faster, and it supports you to your job in an efficient way and reduce the unproductive time.
Thanks, pretty good.
Yeah, Hakim, just taking the opportunity of what you have just said.
Yes.
I know the project that you ran during your period in at Fraunhofer IPK in Berlin, where I worked with you, and I could accompany you next to you, like seeing everything, every step. And it was something that I also started to work because I saw some results that what you have managed so far, and then I just like doing the same, and then I did the same but for other kind of machines, right? And in this aspect, during the period that you were in Fraunhofer IPK, tell us a little bit about your experience in the difficulties of the projects, how to identify some failures in machines, like you used to machining machines like CNC and so on. What was your experience, and which was your main difficulty? Not only about the machine learning technologies, how to identify the failures and patterns in the machines, but also the other side, like the human side. Which were the biggest difficulties that you had, and your experience about it?
Okay, so thank you for this question, because that's remind me to the challenges we had in the past. So one of yeah, indeed. So this was one of the projects where I was involved in, is about retrofitting of the existing production machines. So one of the challenges in the production environment is the availability of the production machines. So especially when it comes to very expensive production machines, so they should run 24 hours, so means 3 working shifts without an interruption, and production interruption is very costly. And one of the issues is also the right diagnosis. So you have an interruption in the production, but you don't know how faster you can repair the machine to bring it again to the production. And this can take a couple of days. So means you have an interruption, you do the right diagnosis, you identify the right failure in the machine, then sometimes you don't have the components. And this time from the interruption to the repair, it can take a couple of days. And a couple of days means there is a huge cost related to the interruption of the production for this period. And in that project, we developed a concept how we can use low-cost sensors with single port computers as an edge device. So it means we had micro electromechanical sensors, so the sensors which are used in our smartphones, so vibration sensors, for example, which are low-cost sensors, and to gather, for example, vibrations, temperature, pressure, and the other signals. And we used single board computer to analyze this data next to the components. So it means very close to the critical components. An example of a critical component is in bearing, so it's in rotating part, which causes the interruption of the machines. So to answer the first question, so what are the challenges? So one of the challenges when we develop the concept, and then we build the sensor network with these layers. So means the first layer is the sensor layer, so next to the components. The next layer is the edge computing, so we will analyze the data. And then we have on the next layer is then the gateway, where we are communicating these insights from the edge devices. And then we have the next level, which is then the cloud, where we measure these data coming from different components. So the first challenge was in how the IT can enable us to have this access, because it's a network which communicates to the IT environment of the factory. So means you come from the production environment and you communicate this data to the cloud using the network, the IT network of the factory. So that was the first challenge, because the IT development, the department is not the expert in the production, is not the expert how to bring these devices from the machines into the IT system, and how to bring this with solving all the security issues. So that was the challenge. The second challenge was when it comes to machine learning based applications. So it means machine learning. So I have to train the algorithms with the right data to get the right detection of the failures. So I need a wide data is required to enable or to achieve a high accuracy of the algorithms. So means when it comes to data driven decision making, I need to know a lot about the failures. So I have to have a representation about these failures to enable the algorithms to work in autonomous way and to detect the changes on the components, the failures. So one of the challenge was how we can get this from different machines, how we can have a description of all possible failures, which is an ambitious target. It's not easy to achieve, because two components in the same machine under the same conditions, they behave different in a different way. So to have a representation of all possible failures, it's quite impossible. So it's only possible if you have thousands of similar components under the same conditions in the same environment, then you can have the anomalies from different components. So that was the second challenge. Third challenge is when it comes to people, I mean to operators, to our team, which was working on these projects, how to find someone who understands different parts of the engineering. So we needed people who can implement algorithms, so means understanding software development, understanding new programming languages, for example, Python and open source platforms, but at the same time, they have to understand the behavior of the machines. So means they should be aware of the mechanical laws, of the rules of the PLCs of the machines. So means the control units of the machines, different control units. They have to understand the communication protocols in the machines or between these different devices. So means we needed someone who can speak different languages. So means he can speak the IT guy language, which is the implementation, software development, at the same time a technician language. So means understanding the mechanical behavior, understanding what happened when there is a moving part in the machine. And you have someone who should understand at the same time, the same one has to understand the measurement technologies. So with which parameters of the sensor I get the best accuracy of the signal. And then you have someone who should understand the whole architecture. So means what I need to have a comprehensive application from the field to the cloud, and what I need for each step. And then at that time, one of the huge challenges we had is the cybersecurity, as I said, how we can integrate this in the IT environment of the factory. But we could solve.
In short.
We solved.
Yes.
Yeah, I just want to comment something on that.
Yes.
I was close to you, right? A room away from your room, from in the same department as you said, and I could see everything that you have done, and also how big it has become. Like this main idea of putting the intelligence on the sensor node, there on the machine and the component, became a big project that was on one of the biggest projects of the institute at the time. And it was so big that a software company, went inside to the institute, right, Hakim? And because they should test and they should develop something really focused on these machines and on this architecture. And it was a great. I could present some of your results in some fairs in Germany. All based on this gathering of sensor data and put it on a virtual reality inside of an environment, a platform. And as you change the component of the machine, that you could read a barcode and so on, QR code, and it goes automatically to the virtual machine. It was really amazing to see that, and all the data that you had in the field, you had it on the cloud, and you could see in a real time. And also, you could also observe with the camera. It was really amazing because you had only low-cost sensors. Was Raspberry Pis, Arduinos, and so on. Everything with the solution. That was really impressive and amazing because it didn't cost a lot of money. That what you need was the idea, of course, and then the idea to implement and try to get some money, sometimes from your own pocket, right? We live that, and then when you put the ideas with your team into practice, it was really amazing because the results were really big, and then it became a project. And then a lot of big companies went in. That was the most amazing thing that I saw. From a small idea, it became a really big project with a lot of companies involved. And also you have, as a result of your doctorate work or doctoral title, you had this solution, and you also had a platform for identifying, it doesn't matter which kind of data. Using machine learning algorithm, you could identify which algorithm and could test with any kind of data. That was amazing. It was also the basis of a lot of work that we wrote together, articles, papers, and so on. Because this platform, this tool that you have developed with your team was so flexible that you could use anything that you want. And it's this for the industry was so useful that it became a product for another company, and also the solution in cloud, the services. And I think this is amazing because you productized an idea, and from this idea you turn it into reality. And it's something that the idea also from rodaTECH, the tech wheel that we used to this program here, is to highlight this kind of things, and also to highlight how you were inserted in the innovation ecosystem. In Berlin, something different. Germany has this ecosystem very strong. You need to be an entrepreneur at the end of the day. You need to develop ideas, and you need to push it forward. Otherwise, you will not survive. And
that's
right? Am I wrong or am I right?
Correct.
And then if you don't do this, and from this work, you put your PhD title, from ideas. And some people think this is impossible. You need the government. No, you don't need you need the government sometimes. You need the idea. You need to bring it to the reality. And then you go to some calls, project calls, and try to bring some investors. But the beginning, like you said, it needs to be simple as possible, not that simple, but as simple as possible. And it needs to be focused on the objective and the goals of the company. A business goal, a business case should be really clear. And another thing is, we know that's not easy. Some people think that it comes from the night of the day. It's a lot. How many years you were there? 7 years, 8 years?
7 years, yeah.
7 years, and it became reality after 6 years, I think, or 5 years, right? And
yeah, it takes time to
see how many.
Yeah, I mean, it takes time to have, especially when you are developing new ecosystems or new solutions, which are not available on the market. So it means you develop everything from scratch. So you start to develop new. But just to comment on this project, Rodrigo, because exactly this was an application which is being used to have a digital twin, because when she asked me what are the emerging technologies, and this enablement with IoT and data, sensor data transmission, machine learning, identifying different conditions of the components, and on the cloud of our software partners, PLM, so product life management softwares, we could have a representation, a digital representation of a real production machine, and then the digital representation in the cloud was used to bring or to show the real or near real data changes in the machine. So it means when we had any changes, so change can be in the process or in the configuration of the machine. So for example, during the maintenance event. So with the IoT, which Rodrigo was explaining, with QR code and sensor data, we could change the configuration of the digital twin in the cloud, and so you can have a record of what happened at the machine with the time, which is now getting also an application in manufacturing. So digital twin is almost one of the terms which you hear everywhere. So you have a product, digital twin.
Yes. You must have historical data. That's something that if you see some failure, especially for those that are trying to identify the failures in components and machines, if you don't have historical data, you are nothing. Of course, there are some algorithms that you don't need to teach them to say that's a failure, but they are really advanced. But in the middle term, in the middle knowledge of the people, we need to say that this is a failure, so I can teach the algorithm, and then he's gonna learn. Okay, this is a failure. Next time I'm gonna try to identify before it happens. But if you don't have this data, you are out. It will break again, and you don't know why. And it's also important for analysis when we are talking about quality, and it also improves and makes the quality of the components of the workpiece that's being built better or worse, And if you don't have this data, you are out. You cannot analyze what happened, at least. And we are talking about Industry 4.0. We have this four step that's to analyze what happened, to analyze its diagnosis and so on, to analyze what's now, what happened before, what's happening, what's gonna happen, to predict, and then to give some recommendations before it happens, because it's gonna happen, And you have these 4 steps, and the first step is to collect the data. It's the basics. Yes. And if you don't have these basics, you don't have anything. You could not allow the digital twin if you hadn't do that, Yes. If you hadn't do this, and it's something that hadn't done it, and it's amazing. Like when you see it in the reality, and that's something that we want to push in the people that's watching us, people that are watching us, and also right now or later. Nothing comes from the night to the day. everything needs time to get mature and to see if it's really mature for it generates value for the customer. And in this case, you had the purpose, and it brought really big value for the customer, because in a machine that's really expensive, every time that it's stopped, it's waste of money, and it's a lot of money. And also the component, when it breaks, it costs a lot to manufacture it. So that's the example that you have just experienced and told us. It's amazing, man. Thank you very much for this exchange. Rafael, please, I interrupted you.
No, fine. Any questions? I mean, I'm here to answer also your questions. I can I can talk a lot about the project, but but it's also
no problem, my friends. Oh, the talk is very interesting. Well,
please.
Hakim, when we think about the appearance of a new field like Industry 4.0, it always appears some companies that tries to make standards, establish guidelines, or something like that, defining the best practice or best technologies. So my question is going in this sense. Is there a global alliance to deal with issues of Industry 4.0? Are there some consortia or association that is worrying about to organize the Industry 4.0? I know Germany is the first country to publish the idea of Industry 4.0, but you have some knowledge about some consortium or some global alliance?
Yeah, I mean, this is thank you for this question, Rafael, because this is really one of the challenges which we are facing when it comes to applying technology, Industry 4.0 technology. So there is no standardization of the protocols, no standardization of the devices. So to answer your questions, so yes, there is a movement between some companies, international companies, they are trying to push one of the communication standards. So when we are talking about data-driven services, data-driven applications, means it's about data exchange in the production. So from the different devices, and these devices, as I said, use different protocols, and you have different market leaders or different market players. So you have Siemens, for example, you have ABB, you have in the US and Japan, other manufacturer of the automation components. And to answer your question, yes, so there are some initiatives between those market leaders to use at least one of the standards, so to focus on development, one of the communication standards. So an example for manufacturing is the OPC-UA as a communication standard for Industry 4.0 data exchange in manufacturing. But we're still at the beginning. So it means there is not a huge interest even from different vendors to have one standard, because we're still at the beginning, but there are some standards also pushed from the IoT platforms. So it means when cloud solutions are applying to enable applications, they are supporting some of the protocols. So it means at the end of the day, we need one standard to communicate with these platforms, which we don't have today. But there are some initiatives to answer these questions, and we're still at the beginning. So directly related to Industry 4.0, there is a reference architecture was defined in Germany, for example. Some of the countries, they took it and as it is, and then they try to apply it as a reference architecture. It's an open source, but as I said, in each country, there are market players, there are market leaders that have other interests or follows other interests, and they don't want to use the standard of the other vendors, because who has the standard has the market lead, and this is the commercial part of Industry 4.0. But I'm sure we will have one day at least an integration platform that supports different vendor devices, because this is important to have the integrated solution in a factory, and it's impossible to have one vendor inside one factory. You have always different vendors and different devices, different protocols.
Perfect. Thank you.
You're welcome. Other questions?
Yeah, I have one question here. We have still have 5 minutes. We can,
Okay.
if you have, we know that there's 7 hours from here, from Brazil to Dubai.
That's
I
fine.
think it's a little bit too late for you, but I would like to. Actually, there are 2 questions too, so we can finish this panel. The first one is, what tips would you give to someone that wants to, or industry, or someone that wants to implement some Industry 4.0 to become more competitive, or to do a roadmap? What would you recommend? Which tips would you give?
So the first step I will go to is understanding what are the pain points of the factory. So means, what are the challenges which I want to solve with Industry 4.0 technologies, or with the digital transformation. As I mentioned at the beginning of our panel today, so for example, cost reduction, operation cost reduction, product cost reduction, development cost reduction. So then when the pain points, the challenges are identified, I have to identify also KPIs that I can measure if I implement data-driven decision making, how I can measure it, how I can measure if I implement an IoT solution in the field, in the shop floor, to avoid any interruptions. So how can I measure it? So it's probably easier if I have, for example, 20 interruptions per year, then after I implement the solution, I would have probably only 2. So then I reduce the number of interruptions. So first, identifying the pain point, describing these pain points in a way that are business cases, and each of the business case has to provide a clear target and a clear steps how to get there. And the first step in all factories, in all interests of the implementation of Industry 4.0 is to understand the readiness of Industry 4.0 for the factory. So means, do I have an IT that supports the communication in front of the factory? Do my machines are able to communicate with the other systems? So there are so many readiness checklists, matrix, where I can at least have an idea what I have already existing in the factory, and how I can build on this to achieve the roadmap different steps. Then I define the different step based on the readiness which I have.
Great. Rafael, do you have any question? I have the last one.
Okay, very fast.
No more.
Last one is,
I'm very satisfied. No, that's good.
What?
That's good. I'm very satisfied. No question. That's
no
good.
question. The last one that I do have is, what tips would you give us as a small state that does not have a strong industry, but we have a strong tourism industry? What tips would you give us to do such Industry 4.0 roadmap? I think it's a little bit the same, but focused less on the industry, but more on the tourism.
Yeah.
Would you give the same tips, or would you?
I mean, yes.
In our innovation ecosystem, that is still
I mean, when it comes to smart products or smart services, they can be implemented in a manufacturing, they can be implemented in medical care environment, they can be implemented in tourism environment. So it's always about how to enable decision making based on data, how to communicate data, how to gather data, and how to have an infrastructure that supports everything is digital. So it means if we talk about tourism, for example, or e-health, then the same technologies or similar technologies are applied. So it means I need a cloud platform, I need a cloud infrastructure, I need smart services. Smart services means I need to gather data, to analyze data with machine learning, which is similar to the industrial environment applications. So at the end of the day, same technologies can be applied in different domains, including any other domain to manufacturing. So health, for example, is similar, tourism, logistics, whatever.
It's a great idea, great highlight, because smart services don't need to be at the place there, right? We can be anywhere. Like in Hawaii, we could be at Hawaii. In Hawaii, just spend time on the beach and working for someone in China or in Germany.
Yes.
I do have one question, and I think this question is gonna like. I'm gonna put on the screen here. From Clayton. Hey, Hakim, wie geht's dir?
Wie geht's dir?
Good.
Clayton Müller was a student from us. He's a Brazilian guy. He was at the last event as well. And I think, Clayton, I really hope that you're enjoying seeing us. And I thank you for the participation as well. And please, man, you need to answer, Clayton. Come on.
Ja, I'm good. Also ich bin gut, danke. Mir geht's ganz gut. Ich hoffe, dir geht's auch gut. Ja, it's also a pleasure for me to be with you today and to discuss these very interesting topics in the Industry 4.0 digital transformation, or IIoT, how they call it in the US, is all about how to apply new technologies, emerging technologies to enable the products of the future. But it's, at the end of the day, always about being more flexible, being more aware of the decisions. So it means the decisions are not made based on some unsecure knowledge, some unsafe situations, but it's based on data. So it's more secure to make the decisions. You have more assurance when it comes to the quality of the products and the processes and the services.
Okay. Hakim, thank you very much, man. It was a pleasure to have you at the program. Thank you very much for your insights, your experience, for exchanging this with us. Rafael, thank you very much again.
Thank you so much. Hakim, Dankeschön, mein lieber Kumpel.
Gerne gemacht. So,
man,
so good.
Thank you very much again.
You're welcome. So good afternoon then to you. So have a nice weekend. And,
thank you. Pessoal, muito obrigado por vocês terem assistido. Foi um prazer tê-los aqui também. Se tiver alguma dúvida, entre em contato. Esse foi aqui o nosso primeiro rodaTECH International com o Dr. Engineer Hakim Laghmouchi, que hoje está em Dubai. É gerente da parte de arquitetura, soluções de arquitetura, né, Digital Transformation, na Capgemini and Altram Group. And ele está desenvolvendo muitos projetos na área de indústria 4.0. É uma das pessoas que eu conheço mais expert na área, que mais botou a mão na massa aí, que tem know-how para ajudar todo mundo aí. Então, espero vocês no próximo rodaTECH daqui a 15 dias e eu espero que vocês tenham gostado. Até a próxima.
Tchau.
Bye, bye.
Bye, bye.
Thank you.